Hi everyone, so this video is on molarity, or what we call the concentration in a solution. So a lot of times when we deal with moles of things, we will have solutions of substances that we mix together. For instance, instead of having a solid, so our first lab we had a solid and we heated it up, but sometimes we'll have a beaker, and then in the beaker we have a liquid, and in the liquid there's something dissolved. Okay, so there's something dissolved in here, and the thing that's dissolved is called the solute. Now this is oftentimes a solid, but it can be a liquid, so you can have things like alcohols or whatever. So you could have a liquid or a solid, but the definition of molarity, or the molar concentration, is the moles of something in every liter of solution. So let me give you an example here. So molar concentration, let's say I have a solution of calcium chloride. Calcium chloride is road salt, and if I have a 0.352, this term here I would say is molar. If I have 0.352 molar solution of calcium chloride, what does that mean? That tells me that if I have a beaker, and in this beaker is 1 liter of solution, then in here, dissolved in here, I have 0.352 moles of calcium chloride. So this notation here, this big M, I actually don't like the big M, but they use the big M to signify two different things. So I'm going to write this out. So make sure you write out this information. So the way they translate that is 0.352 molar actually means 0.352 moles of CaCl2, that's what this thing is, in 1 liter of solution. Okay. Now, and I'll say one more thing. If I take this, let's say I pour out a little bit. So if I take this solution here, kind of like lemonade or whatever, Gatorade, and you pour out some solution into a smaller beaker. So let's say I take only part of it and put it in here. Do they have the same concentration? And is it the same stuff? It is the same stuff. So even though I don't have 1 liter here, you can still have the same concentration. So this thing here still is 0.352 molar because it's the same substance. It's the same concentration. We haven't changed the liquid at all. We're just changing the total amount. So concentration just tells me how strong that thing is. How do I solve for molarity? So the molarity formula is as follows. The molarity, so molarity or molar concentration is equal to moles of solute divided by liters of solution. Okay, so moles divided by liters. This number here has to be in liters, so we'll talk about what happens if it's not in liters, but I have an example down here. Let's say I have 0.295 moles of calcium chloride, and I dissolve it in 0.49 liters of solution. What is the molarity? Well, this is not a full liter, So how do I solve for this? You can just take the formula. Molarity equals 0.295 moles divided by 0.49 liters. I go ahead and punch that in. 295 divided by 0.49, and that gives me 0.602. Okay. And the units for that are, you would just say big M or molar, or you can say 0.602 moles in a liter, or moles of CaCl2 if you want to be more specific. CaCl2. But that's how you write that out. So the formula, pretty straightforward. Calculate the molarity. Now, in the lab, a lot of times we might have solutions that I can't weigh out moles on the scale. I have to weigh grams out. So in this case, let's say I have 17.3 grams of CaCl2, and I'm dissolving it in 280 milliliters of solution. So milliliters, we know, are different from liters. What's the molarity? So how do I do this? Well, grams, we got to change that to moles first. I give you the molar mass here. I'm going to take 17.3 grams CaCl2, and then I divide it by the molar mass, so 110.98 grams in a mole. And that is 0.156 moles of CaCl2. Well, now I have milliliters. And remember, my formula says molarity is moles divided by liters. So you have to know the relationship between milliliters and liters. In this case, milli means 1/1000th of something. So 1 liter equals 1,000 milliliters. If I want to convert that using dimensional analysis or some other way you call it, I can take 280 milliliters over 1. I want to convert to 1,000 milliliters on the bottom, 1 liter on the top, and end up with 0.280 liters. Now, if you know this conversion in your head, you can do this in your head, because what happened to the decimal point for this? Well, the decimal point here is 280. I divide by 1,000, so you're just shifting it 1, 2, 3 spots over, and you get 0.280. So if you know this conversion and you get comfortable with it, go ahead and convert milliliters to liters right away. And now I can do my molarity calculation. So molarity equals moles divided by liters. That equals 0.156 moles divided by 0.280 liters. Take this, 0.156 divided by 0.280, and my molarity is 0.557, and it's molar, or 0.557 moles per liter. Okay. Now, what if I have to do the other way? So let's say I have milliliters and molarity, and what if I need to calculate moles now? Okay, So I'm going to take this milliliters, and I know that that is 0.150 liters. And now I can do this one of two ways. So there's two methods to do this. The first is I'm going to look at this formula. So molarity equals moles divided by liters. I know that 0.41 molar is my molarity equals moles divided by 0.150 liters. And I gotta solve for this. So how do I do that? Well, if you want moles by itself, I can take liters and multiply both sides by liters. And now I get moles by itself. So the way to rearrange this formula is molarity times liters. I'm just reversing them. Equals moles. Okay, so moles equals molarity times liters. Excuse me. And then I can go ahead and plug this in. So moles equals molarity, so 0.41 times liters, 0.150, and that equals 0.41 times 0.150, 0.0615 moles of MgSO4. So that's the first way of solving this. The other way to solve it is by using proportions. So I know that this unit here, 0.410, so 0.41, 0.41 molar is the same as saying 0.41 moles in 1 liter. And so if I know that 0.41 moles in 1 liter equals some X moles in 150 milliliters, or 0.150 liters. Okay, so remember my volume is 0.150 liters. I put that in the bottom here. I know that this proportion has to stay the same, and now I solve for X. And to solve for X, you cross multiply and divide. You take this times this, divide by this. So 0.41 times 150, 0.150 times those together, divide by 1, you get X equals 0.0615 moles. So either way works. It's the same thing, but I like using proportions because then I can see how everything works out. So in this problem, suppose I need to take 0.195 moles of MgSO4 and I want to make a 0.83 molar solution. And now we got to figure out how much liters I need to make. So in this problem, I know 0.83 molar equals 0.195 moles divided by L. And I got to solve for L. Okay? So my two methods of doing this, my preferred method is, well, I know 0.83 molar equals 0.83 moles in 1 liter, and that equals 0.195 moles over X liters. Okay, and now I gotta solve for X. Well, cross multiply this, so multiply this together, and then divide these two. So cross multiply this and divide. So 1 times 0.195, which is just 0.195, divided by 0.83, and then I get X to be equal to 0.235 liters. So that's one way of doing it. The other way of doing it is if you know the formula already for moles. So remember, moles equals molarity times liters. Well, I want liters by itself. So I'm going to rearrange this and say, well, I divide both sides by molarity. Then I know liters equals moles divided by molarity. So I can take liters equals 0.195 divided by 0.83, and that gives you the same thing, 0.235 liters. So you can solve this either way. It's the same thing, just a different way of setting it up. And then the final thing that I'll talk about is sometimes we want to know the concentrations of certain things. So suppose I have a solution of calcium chloride, which is 0.37 molar, and I want to find out the concentrations of just Ca and just Cl. Okay, so the way that we write this is molarity can be written in different ways, but the bracket tells me that means the concentration of, or the molarity of. Okay, so it tells me CaCl2, the concentration of that is 0.37 molar, or 0.37 moles of CaCl2 in 1 liter. If I look at how this is dissolved, if I dissolve this in here, that means I've got some CaCl2, but when you dissolve it, what happens is, if I put CaCl2 in here, it starts breaking apart. It forms into Ca2+, it forms into Cl negative, okay? But if you look at the formula, what do you notice about how many Cl's there are compared to Ca? Well, for every Ca, there are 2 Cl's. So Ca, you have 2 Cl's. Ca, there's 2 Cl. We did a little bit of this last year with the nail lab. So, are the concentrations going to be the same? No. What is the Ca concentration? Well, for every mole of this, it's just 1 mole of Ca. So those concentrations are going to be the same, 0.37 molar. Okay, because for every CaCl2, there's 1 Ca. However, for every CaCl2, there's 2 Cl's. So my Cl concentration is going to be twice the amount of this number, so 2 times 0.37 because of this coefficient, this number here. And so that gives me 0.74 molar. So Cl negative concentration is double the one of Ca because for every Ca there's 2 Cl's. Okay, so hopefully get those down and we'll start doing some other work with these notes.